So how we measure the time complexity for the different operations we'll do. So this is like a very standard syntax or the code template that you can use for most of your code that you're doing. Okay, so let us say in this code I'm going to only print some star symbols. Okay, so I'm going to print 1,000 such star symbols, and I want to know how much time it takes to print 1,000 stars. That's my objective of this program. How long it takes, the physical time, how many seconds or milliseconds or nanoseconds, whatever the time it takes to print 1,000 stars. So how to measure that time as part of your code. So in order to do that, you need to include these actually three packages: ctime, ratio, and chrono. So these are the three header files that you have to include as part of the include statement. Then of course you have using namespace std. Now inside the main function you include another using namespace statement. So using namespace std :chrono. So this chrono is going to be like a package that you want to use for the time functions. Now this is also kind of a high level class implemented inside the chrono package. So high_resolution clock is a built-in name, class name. Then time_point is also a class within the chrono package. So you put :time_point like this with high resolution clock. Now T1 is an object of class time_point. So T1 could be any name you could come up with, start time or any time, any name for the time. So I just say T1. And then its value is initialized or assigned to be the current system time. So when you call the now function on a high resolution clock class, so this is like a static function. So it's not an object. So you're calling the function on the class itself. So high_resolution clock now will return the current system time, and that will be stored in this T1. And then this is where you will do whatever you want to do. So here I'm going to just print 1,000 stars. So instead you want to do insertion or deletion to the list. You can include the entire all the what you call in your main function. You can create the, of course you would create, if you don't want to measure the time for creating the list, just create the list ahead and start the timer just to measure the time for the operation that you want to do on the list. Okay, so here I'm just going to print 1,000 stars, but if you want to do 1,000 insertion operations or 1,000 deletion operations, so you can place the timer accordingly. And then once you're done with the operation for which you want to measure the time, measure the system time again. Okay, so write the same statement and just have a different name for the time point object, says T2. So it's just like before you do any operation, you start a timer, do that operation, and then measure the system time again, and then you're going to take the difference of the two time values, T2 minus T1. So that's going to give you the time that you spent to do that operation or function. And the difference is going to be of this type. You're working with time_point. Okay. Now there is a duration package inside C++ and built in the chrono file, header file. Now you can the difference you want to eventually store as a double or print as a double. And then how you want to measure the difference, in what time unit you want to measure the difference. You could measure the difference in 3 of these time units, whether in nanoseconds, microseconds, or milliseconds. So these are the keywords. If you want to measure in nanoseconds, use std:\nano. If you want to measure the difference in microseconds, std:\micro. If you want to measure in milliseconds, std:\milli. And this is some name you could come up with. I just came up with this name, time_span nano. So you could say time difference or time, whatever the name you want to come up with, doesn't matter. So but duration is a built-in class, and this syntax is going to be the same. So the only name of the variables or object that you could come up with is like T1, T2, time span, nano is something you can come up with. Okay. Similarly for micro and milli. So you can get the difference in all the 3 time units simultaneously. So that's a good feature. Then you can print out the time it took you in milliseconds, microseconds, and nanoseconds. Now, how you do that? So on this object, time underscore span nano, you call the count function on this object. So this is an object of class duration. So in what time unit you want, so you can then call the count function on that object. Again, this is some object name you could come up with of type duration, of class duration. Call the count function in that class, and that will print whatever the time argument you passed here to create that object. So this is like basically creating that object and specifying that you want the difference captured in nanoseconds. So when you say dot count, accordingly the value, the magnitude will be in nanoseconds. If you say micro, the magnitude will correspond to microseconds and then milliseconds. So this is a kind of template for measuring the time, or the physical time it takes for your program to run, okay, or any functions that you want to implement to run. Okay, so start using this. So you see the numbers I have given for the code. So I say code 6, then sometimes code 8 and so on. So in Canvas I have uploaded all this code, the complete code. So it will be code 1, code 2, or 2.1, 2.2, I don't remember the way I number, but this, now the second number 2.1, 2.2, 2.3 means module 2 code 1, like that. So this is code 6 under module 2, so it might be as 2.6 in Canvas. Okay, so but the numbers will correspond to the problem. So download all this code and practice these things. Okay, any question?